Good morning children. We will be doing the revision for our upcoming exams. For that we will be having lessons number 4 and 5. In our physics we are having lessons 4 and 5. Okay. What is our fourth lesson? Our fourth lesson is light energy. Okay. We know what is light. Light is nothing but an energy. It is also a form of energy which enables us to see the objects. Is it not? We have already learnt that in our second lessons. Is it not? In the forms of energy. The first energy we saw was the light energy. Light energy is nothing but which gives the sensation of vision. That is, we are able to view the objects only because of this light energy. Now, here we will be learning about the laws of reflection and the properties of the images formed due to the plane mirror. That's all we are going to see in this lesson. So first, what is reflection of light? Reflection of light is the typical English meaning for word reflection is going back. Okay, that is, it is going to go back. It is going to be reflected back. So the reflection of light meaning means the bouncing back of light. Okay, the bouncing back of light from the surface. From the surface where it is falling is called the reflection of light. That is how we are able to view the objects. That is, when the sun's rays fall on the objects, it can be a tree, it can be a car, it can be anything. Whenever the sun's rays or the sun's light falls on the object, the rays are getting reflected. It will not go back to the sun again, but it is scattered. So that is how we are able to view the object. Okay, so now we are going to see what are the laws of reflection. Before that, you should have a plane mirror. Okay, and that we are going to incident a ray. This incident ray is the ray which is going to fall, okay, on the mirror, and the reflected ray, that is, it is getting back outside. So that is why it is called the reflected ray. And then there is a normal. Okay, the normal is nothing but which is drawn perpendicular to the point of incidence. Normal is nothing but an imaginary line which we draw, which is perpendicular to the point of incidence. That is, point of incidence is O. Okay, from that point we draw a perpendicular, and that is called as normal. And now we will be having two angles formed. We know the angles are named as AON. This is called the incident angle or angle of incidence. Okay, then there is another angle called NOB, and that angle is called as the reflected angle or angle of reflection. Okay, that is what the law will say, that the angle of incidence is equal to angle of reflection. Okay, and there will be a incident ray, then there should be a normal ray, and then a reflected ray. So these are the two laws which you will be seeing here. So first, what is the incident ray? The ray of light approaching on the mirror is called the incident ray. Approaching or falling. Falling means it should touch that point. Okay, the point where the incident ray strikes the mirror or touches the mirror is called the point of incidence, and the ray that bounces back is called the reflected ray, and the line drawn perpendicular to the point of incidence is called the normal. Okay, now coming to the laws. First law. Okay, what is the first law? The incident ray, the reflected ray, and the normal all lie on the same plane. That is, this plane is the surface of the sheet, or it will be on the surface of a table or a desk. So they all should lie on the same plane. Okay, and then the second law of reflection says the angle of incidence is equal to angle of reflection. Okay, now coming to the types of reflection. What are the types of reflection? We have two types. One is regular and other one is diffuse. What is this regular reflection? Regular reflection means it is a clear reflection. First point. Okay, the angle of incidence will be always equal to the angle of reflection. That means when the number of rays or any number of rays which are parallel to each other, when they fall on a smooth and highly polished plane surface, that is, when a number of parallel rays fall on the smooth and polished plane surface, their reflected rays also will be parallel to each other. Okay, so that will give you the regular reflection. Okay, so the regular reflection will give us a clear and sharp image. So it will give us the clear and sharp image. Okay, then if it is diffuse, that is when the rays of light are falling on a irregular surface or a rough surface, then the reflected rays are also in scattered version. Scattered, that is it is not parallel to each other. So this is also giving us the diffused reflection. So this will give us the blurred image. Okay, so where are we applying this application? For calm water surfaces, we can take the complete picture. Okay, the picture will be very clear during the photographs of the scenery. Whereas if the surface is not clear, that is if the water surface is turbulent means there is some waves or something is disturbing the calm water, the photograph would also be disturbed. Okay, then coming to the images formed by the plane mirror. This you will be encountering daily, is it not? Whenever you look your face at the mirror, your right hand side will be considered, or it will be looking like your right hand side will be the left hand side and your left hand side is the right hand side. So that is called lateral inversion. Lateral means your sides. The sides are inverted. So that is called the lateral inversion. So the image formed by the plane mirror will always be laterally inverted. It will be laterally inverted. And then how are we making the mirror? Mirror is formed when the glass, one side of the glass is coated with silver polish or silver paint or some other coating. Okay, and only one side is reflecting. When the glass is coated on one end with a metal coat or anything, then you will be getting the mirror. Okay, so that is how we are going to see the image formed in the mirror. How are we going to see the image? See, look at this. Here we are having, this is the plane mirror. The red color thing is the coated surface. Now O is the point of incidence and OX or OB is the normal. Okay, so when the light ray is passing or it is passing through O, what will happen? It will be reflected as in the form of OY. So the angle of incidence is marked as I, angle of reflection is marked as R. Now, where will be the image form? That will be the question. Okay, so we are going to talk about two cases. The first case is the first ray. Okay, the first ray OY. OY is reflected because the reflected ray is OY. Now, when you consider OB, when OB is considered, the angle of incidence is 0. That means the angle of reflection also will be 0. So the rays will be reflected back like this. Okay, so that is how we are going to see the image. The image will be formed, that is it is extended back. The image is extended back. That is this object is the extend back. This line is extended behind the mirror. So we call this as the virtual image. Virtual means somewhere we have to catch this. Okay, so the virtual image is formed and the image will be of the same size of the object and then it will be of the same height and it will be from the same distance. So the size will be the same, the distance will be the same and the image is formed as virtual image. So that is what we are doing. We have found out from this experiment also. Okay, the virtual, it is reversed, that is laterally reversed. It will be erect and it will be of the same size. Okay, then coming to the lateral inversion, that is what? The phenomenon in which the image of the object appears to be left-right inversion is called lateral inversion. Okay, then coming to the characteristics formed by the plane mirror. The image formed by the plane mirror will always be virtual and erect. Virtual and erect. Then the image undergoes lateral inversion, and then the size will be the same as that of the object, and the object distance will be equal to the image distance. Now coming to multiple reflections. Multiple reflections, nothing but when you are going to use more than 2 mirrors. Okay, you will be having this phenomenon called multiple reflection, and it will be depending upon the angle between the mirrors. It will be depending upon the angle between the mirrors. Here we came across 2 objects, that is, one is a periscope and other one is a kaleidoscope. Periscope means is mainly to see the object situated at a higher level, whereas the kaleidoscope is simply for making some colorful patterns. Then the main thing is the speed of the light. The speed of the light in vacuum, that is where there is no air, it is 3 into 10 power 8 meter per second. It is denoted by C. Okay, then it is the speed of light in transparent materials is less than that in vacuum. Then coming to the primary colors, the first color is the white color. Okay, from there you will be getting 3 colors: red, green and blue. If they are mixed in the proper proportion, you will be getting the white color. So red, green and blue are called the primary colors. Then formation of the secondary colors. When these colors are mixed, see this diagram, when the R, G, B is all mixed together, you will be getting the secondary colors such as yellow, magenta and cyan. Okay, then we are going to see the addition. We saw this is the addition of the primary colors to get the secondary colors. Now we are going to see the reverse, where we are going to see the subtraction, that is removal of the colors, primary colors. You will be getting the black. So the removal of the total colors, when there is no white, you will be getting only the black. That is, the black is due to the absence of light. Okay, now we are going to see the question and answers in the exercise. The ray of light falling on the mirror is called incident ray. If the angle of incidence is 30, then the angle of reflection is also 30. The primary colors are red, blue, green. The speed of the light is 3 into 10 power 8 meter per second. The phenomenon of the reflection of light many times is called multiple reflection. The image is always erect. Okay, it is not inverted, it is erect. Then the mirror, which is of the same size of the object, means it will be a plane mirror. And when cyan is mixed with blue, okay, you will be getting only green. Okay, and yellow is the primary color, secondary color. True or false? The LCD in the television are used as additive color concept. True. Appearance of the color of an object is due to refraction. No, it is false. Red and green combine to form a secondary color. True. The image formed by a plane mirror is always virtual and erect. True. A carrot will appear to be orange because it will be reflecting only the orange color, because the colors of all the objects are reflected, because that color only is reflected. Okay. Then coming to the matching, plane mirror you will be having the lateral inversion. Primary color you will be having blue. Secondary color you will be having magenta, and the periscope you have the example for multiple reflection. Okay, naming the following or the name the following questions. The bouncing back of the light is called as the reflection of light. Okay, the phenomenon in which the image of the object appears to have a left-right inversion is called lateral inversion. The other question and answers I have given you in the text format. Okay. The next lesson we will see in the this next lesson is heat. Okay, what is this heat? Heat is also an energy where the hot temperature or the cold temperature is flowing from one body to another. Units of heat, we have 2 units. One is the joule, other one is the calorie. SI unit is joule, so we are bothered only about a joule. So 1 calorie will be equal to 4.2 joules. The combustion, you know, combustion is burning in fire. What are inflammable and non-inflammable? Inflammable, the substances which catch fire easily. non-inflammable, which do not catch fire easily. Temperature, the degree of hotness or coldness of an object is called as the temperature, and SI unit of temperature is Kelvin. Then the measurement of the temperature is done using the instrument called thermometer. Parts of the thermometer: bulb, stem and scale. Bulb is the place where mercury is there. Stem is the small capillary tube through which the mercury will arise when the temperature increases. And then there's the scale, which is marking according to the scales where we are using, whether it can be Celsius scale, Fahrenheit scale or the Kelvin scale. We have 3 scales. In the Celsius scale, the freezing point is 0 degrees Celsius, boiling point is 100 degrees Celsius. And in Fahrenheit scale, it will be 32 degree Fahrenheit and 212 degree Fahrenheit, the lower and the upper ends. In between, you will be having 180 small divisions. And the Kelvin scale, it will be from 273.1 15 Kelvin to 373.15 Kelvin. Then this formula you should know. Okay. Types of thermometer: clinical, digital, laboratory. Clinical, it is used to measure the temperature of the human body. Mostly we will be using the mercury thermometer. And then digital thermometer, it is fully made of digital display. Okay. Here we will not be using mercury, we will be having sensors. Okay. Then the laboratory thermometer, it will be a long thermometer which is used for scientific experiments. Then the precautions for clinical and the laboratory thermometers are given. Effects of heat, what is happening? The rise in temperature, fire and change of state. Rise in temperature, the temperature will be rising. Then fire, slowly it will catch fire. When the body is getting heated, it will be catching fire if it is inflammable substance. Then the change of heat, melting, freezing, vaporization, condensation and sublimation. What is this? Melting from solid to liquid. Freezing from liquid to solid. Vaporization from liquid to gas. Condensation from gas to liquid. And then finally we have the sublimation, directly from solid to the gas. Then the thermal expansion, that is slowly there is a expansion. There will be a small expansion in the body, in the object. Accordingly, the heat transfer can be told as in 3 modes. One is conduction, convection and radiation. So what is this conduction? Conduction means the parts are attached together. There is a contact. Okay. So there is no movement of the particle. So it will be directly transferred. The conduction is the transfer of heat from the hotter to the colder without the movement of the particles. There is no movement of the particles at all. So that is called conduction. How is this acting? In solids, when the particles are very closely packed, okay, the particles will be vibrating. When the vibration is transferred from one molecule to the other, heat energy is also getting transferred. Okay, so we will be having conductors and insulators. What are the conductors? The objects which conduct heat energy are called as conductors. Then we have in the insulators, the objects which do not conduct heat energy are called as insulators. Then coming to convection. Convection means what is happening is when we are boiling or when the heat energy is given or it is transferred, what is happening? The particles will be moving. Okay, so that is when it is getting heated, the particles from the lower bottom will rise up. So once it goes up, it will push the lighter ones down. Then it will be circulating. The molecules will be circulating. That is what is called convection. Okay. So the convection will be occurring mostly in the case of liquids. Then coming to the land breeze and the sea breeze. Land breeze, when the sun is heating in the daytime. Okay. The molecules are getting lighter, they will move up and they will be filled by the breeze which is coming from the sea. So that is called the sea breeze. Then in the night, the reverse will be occurring. That is, the land will be cooling more. Okay, the warm breeze from the sea, okay, will be flowing over the land, and the cool breeze from the land will go to the sea. So this is called as the land breeze. Then coming to the radiation. Radiation means what? Heat is traveling in the form of waves. So now we are going to see the gaseous form, but it will be not requiring any medium at all. Radiation does not require any medium. As an example, all the heat from the sun is radiated to us, and the dark color objects will absorb more radiation than the light color objects. That's all. Then the practical applications, solar heaters and the light colored clothes during the summer. Then working of the thermos flask, it will be having 3 precautions. One is the cap. The cap will prevent heat through convection. Okay, the outside is made up of plastic, so that is to reduce the heat transfer through the conduction. And inside you will be having vacuum, okay, and the shiny surface, that is to reduce the heat loss through radiation. Okay, so all these 3 things you should know, and then we will be coming to the short answers. The form of the energy that flows from hot object to the cold object is called heat. The degree of hotness or coldness is called temperature. In solids, the transfer of heat is taking place by conduction, and in the physical contact means it is conduction only. Then good conductor of heat is copper. Water on the leaves is because of the condensation. The human body temperature is 98.6 degree Fahrenheit, and inflammable material is wood. Then the laboratory thermometer ranges from minus 10 degree to 110 degrees Celsius. Boiling point of water is 100 degrees Celsius. The handles are made up of insulators, and in boiling point the hot water molecules will move up. Dark colors absorbs more heat. Vacuum is to reduce the heat due to conduction, and shiny surface is a part of the thermos flask. Air is a good conductor of heat. False. Okay, in gases the molecules are tightly packed. This is also false. Vaporization of the camphor is an example of condensation. False. The movement of the mercury in a thermometer is an example for expansion of liquids. True. Movement of particles takes place through convection. True. Heat transfer will occur in solid, liquids and gases. No. Because in solids it will be occurring by conduction. In liquids alone it will be doing by convection. The cold air moving from land to sea is called as sea breeze. Radiation occurs only when 2 objects are in contact. No. False. Coming to the match the following. SI unit of heat is called joule. SI unit of temperature is called Kelvin. Temperature range for laboratory, it is from laboratory, so minus 10 degrees Celsius to 110. Normal body temperature is 37 degrees Celsius. And name the following. SI unit of heat energy is joule. SI unit of temperature is Kelvin. Transfer of the heat from a hotter to a colder body is called conduction because of the collision of the particles. Instrument used to measure the temperature is called thermometer. Materials that do not conduct heat are called insulators. The state of matter that expands the least on heating is called solids, and the type of energy used by solar heaters is called the heat energy from the sun. Okay, now I have given all the question answers for both the lessons. Okay, learn all the question answers thoroughly. Learn the 1 marks also thoroughly for exam. Okay, all the best.